If you work in electronics, sooner or later, you will need a magnifying glass or magnifying lenses to be able to work with the ever smaller components. This is especially relevant when working with SMD components. SMD is the abbreviation of the English term, Surface Mounted Device, which means surface mounted component. I spent a very long time looking for a high-quality magnifying glass that offers a large surface area and magnifies the circuit boards and components with as little distortion as possible. As a good illumination is also important, the magnifier should have a powerful integrated LED lighting. Ideally, it would be great if the LED color could be selected, so that the user can choose between cold and warm white LEDs, or even a combination of both options. As I often work on a project for several hours, it would be an improvement if the magnifier could be powered by a power supply, rather than using alkaline or rechargeable sources. After a long search, I found this LED light magnifying glass on the Temu platform. The price seems really attractive, and almost all the features I wanted are available. But unfortunately, does not have the option of connecting a power supply unit. I had to find a solution, and that was to open the magnifying glass and see if an external power supply could be connected. Since the light magnifying glass is powered by three 1.5 volts AAA batteries, it would certainly be possible to operate the device with a 5 volt USB power supply. To test whether the device would also work with 5 volts, I connected it to a regulated power supply. The light magnifying glass worked without any problems or dropouts. Once the question of the power supply had been clarified, I ordered a so-called USB-C Breakout Board from AliExpress. These cost around $3 in a pack of 10. Now it's time to open the housing. Opening the case was a time-consuming process. To minimize any wait time, the opening will be presented in a series of time-lapse shots, highlighting the most significant points with greater detail. I had to find a place in the housing where I could mechanically mount the USB-C Breakout Board. My idea was to mount the USB-C Breakout Board near the on/off switch. Later I explain why this was not possible. But now, let's move on to disassembling the frame. done. That wasn't easy, but it was successful. It is important to open the housing very carefully, otherwise the plastic will break. At the bottom left is the circuit board, where the various light modes are controlled. The positioning of the USB-C Breakout Board would have been ideal near the on/off switch, but unfortunately, the controller board is already located there. Now, a place had to be found for the USB-C Breakout Board. The space is quite limited, and there are not really many positions in the housing where the board could be mounted. The only possible place for the small USB-C board is on the very right side. It looks like it will fit very well, mechanically at least. In order to check if the board could really be installed in this position, I temporarily reassembled the batteries and the housing. This allowed me to ensure that the housing could subsequently be screwed together without any issues. Okay, it seems to be fine so far. I then made a note of the position of the USB-C board on the housing. Then, I used a sharp file and a cutter knife to remove the plastic from the surface. Now, I had to slightly bend the cable to make room for the USB-C board. And then, more cutting, filing, breaking out the plastic housing, but be carefully, because the plastic can break. At this point, a spacer part must be cut out. But be careful, only the small spacer part on the left side. The spacer on the right-hand side is needed to hold the housing together. This is because otherwise, the USB-C board would be sticking out at this point. It is important to keep inspecting whether the USB-C socket fits into the plastic hole. This means continuing to file, cut, and adjust the opening. And file, file, file. Go on. The cutout looks good, and the circuit board fits in perfectly. With a soldering helping hand, the USB-C board can be mechanically clamped very easily and effectively, leaving both hands free to work on the cables or other tasks. In the next step, the power supply cables had to be soldered to the USB-C board. So, a red cable for the plus line, and a black cable For the ground, the other two pins are not needed, as only the voltage is required. With a soldering helping hand, the USB-C board can be mechanically clamped very easily and effectively, leaving both hands free to work on the cables or other tasks. The USB-C board now needs to be fixed mechanically, but first, the black cable must be cut to the correct length, and then the insulation has to be removed. The black cable, the ground, will now be soldered to the control board. And now, the red cable, the positive, is being soldered in place. Now we need a hot glue gun. The brand does not matter. I have been working mainly with the Bosch hot glue gun for several years. The USB-C board must now be fixed to the housing with the hot glue. It is sufficient to apply a small quantity of hot glue to the left and to the right side of the board. The small USB-C board is now mechanically fixed, and can no longer be moved from its position. Now, a small notch must also be made on the upper housing. I have therefore marked the position of the USB-C socket. A small cutout must be made in the housing at this point, so that the USB-C cable can then be inserted. To fix the USB-C board a little more mechanically, I folded up some adhesive tape, so that it creates a slight elevation, and then attached it to the board. Now it's time to screw the housing together, and see if I've done a good job. After the housing has been screwed together, the big moment has finally come. Will the modification work successfully? Perfect, it works as expected. I hope I have been able to show you an interesting alternative to battery or rechargeable battery operation of the magnifying glass. Important note, the magnifying glass should never be operated with rechargeable or regular batteries, and at the same time, a plugged-in USB-C power supply, as this will cause double the voltage to be applied to the electronic circuit board, which will destroy it. It is safest to remove the batteries or rechargeable batteries from the device after using the magnifier. If you have any questions, please write them in the comments section below. If you like my work, click on the thumbs up button, and subscribe to my channel. This helps motivate me to make more videos for you. Stay tuned.